This is Maker Galaxy.
We're always talking about the future of design, the future of technology, the future of making. In a world where we can 4D print self-assembling structures, a world where next-generation video game consoles have become a fully immersive experience, how do we find the next big thing? Maker Galaxy is a show that explores the crossroads of design, technology, and the future of making. Welcome to the show, everybody. I'm your host, Simon Martin, coming to you from NYC at EBD Media's NYC studio. And this week we have acclaimed TED speaker, design thinking author, and Autodesk Fellow Tom Wujec on the show. We'll talk with Tom about everything from his role of bringing the popular Sketchbook Pro digital sketching application to market, where he thinks design is heading in the next 5 years, as well as more insight into his popular Marshmallow Challenge TED presentation. Maker Galaxy is brought to you by CAD Junkie. For those looking to step up their CAD game and stay on top of the latest in software tips and tricks ranging from SolidWorks to Rhino and Modo to Adobe, check out more and get a free membership over at cadjunkie.com. Welcome, Tom. You do so many different things in the arena of creative and business development. If you had to give yourself a single title, what would that title be?
Well, my title at Autodesk is Fellow. But at Fellow, I have the opportunity to do a wide variety of things for our customers and for our organization. I first focus on long-term strategy and explore how emerging, exponentially growing technologies are affecting what we will do in the 5, 10, and even 20-year time frame. And some of that work focuses on emerging technologies such as synthetic biology and metadata visualization and emerging material sciences. I also work with our leadership teams and the leadership teams of our organization, of the customers that we serve, to help them think through the strategic problems, asking them questions such as how are these emerging technologies affecting their new business models. And the third thing that I do is I work with organizations such as TED and Wired UK and many others to foster communities of thought leaders. But if there's really one thing that I do is I help people think through complex problems by using simple and complex images to make their ideas visible, understandable, and clear.
What is your background then, and how did that help shape where you are today as a fellow and somebody who helps others solve complex problems? I mean, where do you get your start doing something like that?
You know, it's a simple question that leads to a strange path. I think many people who work in creative industries start in one place and then they meander around as their interests follow.
Right.
As they follow their interests. So I started in the world of physiological psychology and astrophysics. I took kind of hardcore sciences through school.
Wow.
In Canada, and I realized in physics that I couldn't visualize the quantum physics. I couldn't form a mental picture of it, and that stopped my physics career quite quickly because you can't visualize quantum physics. That's part of the thing of it. But I had this real passion for making the world of ideas and nature and discovery and science visible. It was just something that I appreciated and I seemed to have a knack of. So that interest took me to making documentary films. I ended up working in Canada's largest museum called the Royal Ontario Museum and became its creative director for a number of years. And from there, had a facility and interest in working with computer graphics and computer animation. This was back in the 80s. And worked with an organization called SIGGRAPH, which is a large computer graphic organization.
Right.
And one thing led to another, and I began to do larger and larger animations, I guess culminating with the making of an animation of a dinosaur called a Mysore, which means good mother lizard. There was this huge animation at the time. This is before Jurassic Park came out, of this the duck-billed dinosaur. And in order to be able to do the animations, we worked with a company called Alias at the time to be able to get the software, the high-end hardware,
Gotcha.
produce it. And then one thing led to another, and then after that animation was completed, I shifted over from the public to the private sector, and then began working with organizations to kind of figure out how to do these complex animations, and then had the opportunity to work in different parts of the organization. And after some years, we were acquired by Autodesk. And so that basically put afterburners on our technology in our business, and continue the practice. What was really interesting is as you know, Autodesk is a $2.5 billion company. We're global, and we provide software tools to a really wide range of organizations serving the architecture industry, the manufacturing industry. We help people produce. We generate tools that help consumer products designers of all kinds produce the next generation of things.
Right.
And what's been really interesting is to look at the method by which people apply their creative capabilities. And what's increasingly obvious is that what you do at the beginning, how you frame problems and how you represent the opportunities to be addressed, makes a really big difference in the kind of solutions that you generate. And so what we've noticed over the years is that the organizations that have the most diverse, kind of the most, in some cases, playful and visual ways of representing the problems to be solved, often they generate, in fact, generally, they generate the richest solutions.
Definitely.
Yeah, and that's for people who live in the design world. That's that's kind of obvious, isn't it? Because when you're mapping out ideas and figuring out quite clearly who your customers are, what the market spaces are, what are the where you fit within the workflow. You get three things that happen. The first is people become clearer, right? They become sharper about what the opportunities are.
Right.
Secondly, they get a little bit more engaged when they play and they create work in these large visual rooms. They kind of lean forward more fully because the problems that they're addressing are far more relevant to not only the project, but to themselves personally. They can bring more of themselves in. And then thirdly, when you have these common operating diagrams, common operating frameworks, you get a kind of alignment where people are working to solve the same problems.
Definitely.
So for years, I've been looking at the kinds of ways of making ideas visible and tangible to get to those three qualities of clarity, engagement, and alignment.
Let me back up to when you were talking about switching from hardcore science to creative direction. Where did that creative bug come from, and how did you make that shift that for some people takes years in their career path to switch from a junior level designer to creative director? How did you make that jump? What inspired you to leap?
That's an interesting question. I kind of don't think that they're really different.
Okay.
Strangely. So leadership is what? Leadership is framing context. So people have a shared view of where to go. Leadership also involves creating processes or ways in which people can work together. Leadership also involves creating structures. And finally, I think leadership involves fostering communities of shared values and shared rules and shared resources. Those are four aspects. And I think that the visual tools and the visualization that we do in science, right, making sense of how the world works, kind of shares something deep with the visualization that we do in creating a museum exhibit or a killer great project or an amazing pair of running shoes or an insanely amazing movie or car or fill in the blanks.
Right.
And so the core capabilities I think are the same, but the applications are different.
Definitely.
I think what happens when people become more and more comfortable with their capabilities, their skills, whether it's visualization or whether it's speaking publicly or whether it's creating models of some type, you want to tackle bigger and more interesting problems, and you begin to see what are the real dynamics that are taking place inside of the way in which we work.
Definitely.
And what's been interesting, I think the great privilege I've had working with Autodesk is to really look and see carefully how work gets done. How running shoes are produced, how cars are actually created, how a really great movie is crafted at the beginning, middle, and end, and compare that with ones that are maybe not so good. And what is common to the difference between good and bad outputs is good and bad design principles. It seems kind of really obvious, but it really works.
Right.
Design is both a noun and a verb. Design is as a noun, it's the output of some effort, whether it's a great house, beautiful outfit.
Yeah.
But the design that we study and our customers are so interested in, as a verb, are the steps that one takes to produce the best kinds of results.
Definitely.
And that's a really, it's all about prototyping. It's all about framing and reframing what the core problem actually is, what you're trying to do at a core level, getting to the emotional, the physical, the functional needs of the people that you're serving, figuring out better ways to collaborate by producing better prototypes more iteratively that solve the problem at a particular time in the development process. It's about impeccable execution. And I think when one has a discipline, whether it's super technical or whether it's less so, it seeps into all parts of that design methodology.
And on that note, that kind of ties into your TED Talk back in 2010, in which you present something called the Marshmallow Problem, which is a simple team building exercise that involves dry spaghetti, 1 yard of tape, and a marshmallow. Towards the end of the talk, you say that design is a contact sport. Could you elaborate on this a little more and how it ties into what you just mentioned about prototyping?
Sure. Well, so the just to rewind for a second, the Marshmallow Challenge started off as a great little design exercise to warm people up to get to the task of design. And essentially it consists of having groups of 4 or 5 people work together in teams to build the tallest freestanding structure out of 20 sticks of uncooked spaghetti, 1 yard of tape, 1 yard of string, and a marshmallow. Marshmallow's got to be on top. And you've got 18 minutes to do it. And it seems really simple to do, but it's actually not so simple. And typically in a group of a large group of 50 or 100 or 1,000 people, maybe half, maybe 40% have people have a standing structure at the very end. And I've had the opportunity to do this now, I think it's about just over 200, maybe 220 times.
Wow.
With a wide range of people. And I've collated the results, and I keep the results from each one of these. And what's pretty interesting is to compare and contrast the people who do really well with the people who do not so well. And the payoff of the talk is that kids consistently outperform MBA students. And
of course.
And it's a joke. You kind of go, ha, those who are going to be running the world's financial empire can't
right.
standing structures as well as kids who, when you ask questions, why is that? The kids don't try to be CEO of Spaghetti Inc. They don't spend time arguing like MBA students often do or lawyers do. But it's actually really consistent that people working in certain kinds of industries do not so well at this kind of innovation challenge. And when you look carefully at the reason why, it actually the 2 things happen. One is that kids begin, but back up. When you look at how the 2 groups work to build these structures, they work in entirely different ways.
Definitely.
The MBA students typically begin with a plan. And they figure out who's going to run the plan and who's going to own the plan and who's going to be the guy or gal who gets to put the marshmallow on top. And they write and they sketch and they talk and they debate. And they spend 7, 8, 10, 12 minutes figuring out a plan, and then they execute on the plan. So they actually have very little time to actually build the structure because they've spent time jostling for power and figuring out who does what. And just by watching it, and kind of not even listening, but watching it, you can see the dynamic at play. Kids, on the other hand, begin with the marshmallow And they start playing around, and they stick the marshmallow on top into the spaghetti. It falls over, and then they do it again, and it falls over, and they do it 4 or 5 or 6 times until they have a standing structure.
Wow.
And so the difference is that kids naturally, through the act of play, prototype. They go through that designer's loop over and over and over and over again, producing results. And they're kind of there, present, as opposed to holding on to some mental model of what they think is the right way to do to it. And so what the lesson is that we need to prototype the hidden assumptions in our work. We need to figure out the thing that we think, the marshmallow is just going to stand fine. That's not going to be an issue, until you realize that the weight of the marshmallow typically causes the whole thing to buckle. It's heavier than you think it is. So as a warm-up exercise, it was a great way to be able to to help people create a vocabulary of what they needed to prototype early on, like the customer experience or the feel of the car or the whatever it may happen to be, and to feel free and willing to prototype that as opposed to slavishly following what you think is the right way to do it. And so what's been interesting about that is here's a quiz for you. If imagine a group doing the Marshmallow Challenge normally, say 18 minutes, and then imagine another group or set of groups doing the Marshmallow Challenge in silence. Which group do you think does better?
The silent group.
Yeah, how come?
Because working in groups, and I'm saying this as somebody who does a lot of work remotely. So in some regards, I work in silence. I don't work in a corporate environment. I mean, I used to, but now I don't have distractions. I don't have people telling me to do things one way versus the way I think is right. Mm-hmm. And so by applying that same context into something as simple as building a marshmallow tower, I don't have the distractions or the outside influences telling me I need to do something one way or another way. I'm going to do it how I see is best, and I'm going to work through the prototypes on my own time and with my own regard. So I can see that applying to anything else, really. And then I think where external feedback is important is, I think, coming back and regrouping, in stages, like maybe 4 stages over the duration of this event, coming back and then sharing ideas and then going back and working in silence, if that's close at all to what you may have seen. Or
well, what happens is that the groups with working in silence typically have structures that are 30% taller than those who work in the normal way, talking, and they also finish the structure in usually 6 minutes less. So rather than not finishing in 18 minutes, they have a finished standing taller structure in 12 minutes. So it turns out that talking gets in the way of collaboration for this kind of project where you're doing something that you've never done before with limited resources that people you don't know with. I mean, that's in a way kind of the definition of innovation. So the way in which we work and the constraints that we put on make a big difference. Actually, I was reading in the New York Times this morning of a study that says the constraints, the physical constraints that we have in the way that we work, the size of the furniture, the tabletop, actually has an impact on the psychology of our work and the degree to which we take risks. And it has to do with the amount of physical space and movement that we work in and the amount of movement that we have available to us. It's pretty interesting. So this is one aspect that we study. And the reason we do this, the reason I spend time doing this, is to be able to apply those same principles to the digital design work that our customers undergo when they create games, videos, movies, cars, infrastructure projects, and buildings. The same principles of how you innovate and how you prototype and where you prototype and what the review cycles are apply. It's about creating the right kind of prototype in the right way, in the right place. And that's an important driver. And digital tools are an important part of it, but now digital tools are migrating to social, mobile, cloud, tablets, small devices, smartwatches, glass, large screen displays. So we're in our research groups paying attention to the whole society of technologies, helping foster the collaboration problems, figure out the people problems first, and then provide the right kinds of technology to support the human being as opposed to build up the technology.
Definitely. And on that note, you've written quite a few books that kind of dive into these topics, and one in particular is called Imagine, Design, Create, that focuses on the way that the creative process is changing business and design and where design is heading. So what are a couple of significant case studies in recent memory that you feel are crafting the future of design and innovation in the business structure, as you're saying?
So that's a great question. So Imagine, Design, Create, it's a book that I edited, and we brought several writers together to help tell the story. And what we tried to do in the book is to provide some definitions of what good design is. And that's actually a pretty hard thing to do because different people mean different things by good design. Is this pen, for example, for my tablet here, does this have good design because of the materials that it produces? Are they sustainable? Or because of the way in which it feels, or the cost? And so there's no simple solution or simple definition of it, because design touches so many different parts of both the end result and also the process. But increasingly, good design, we feel, is one that incorporates and touches the system, not just the design of objects. So increasingly, we're seeing in every industry that good design is one that it takes the needs of each of the key stakeholders into consideration, and the full ecosystem, understanding where material or where the input comes from, and then where it goes to. And we're finding that increasingly the best designs are the ones that have not a linear process, but a full kind of circular process, so that the waste of one output becomes an input for something else.
Tell us more about how systems-based design works.
So the shift from designing objects to designing systems is, I think, represents the next phase, or the next kind of maturation of design. Lots of examples in the world of how companies who have looked at the full ecosystem of their business are thriving. A good example, of course, is Apple. We can't talk about innovation these days, can we, without examples of Apple. And so is it the iPod or the iPhone that led to their success? Well, of course that's true, but it was part of the full ecosystem of iTunes and the business model reinvention. So they innovated not just in one place in a product, but in the whole value chain. Similarly, many fast-moving consumer products companies, Nike is a great example, many others, are using a cradle-to-cradle model where they're studying how the outputs of shoes can then be used, how once the shoe has been worn, it can be brought back into the store, and it's disaggregated, so each of the components, literally every part of the shoe, can then go into feeding another process, recycling the soles, recycling the uppers, the last, and so there are economic incentives for people to bring these shoes back, and that drives the innovation model. We're now seeing some car companies striving to do the same thing, so ensuring that the biological components, the toxic components of materials are not fused together, so the material is useless once the car is done, but instead can be designed in such a way that they can be separated when they're returned, so that it provides the circular return. So the looking at entire systems, I think, is where design is enabling us to go, and certainly software tools are evolving so that we can incorporate biomimetic practices. That means looking at how nature solves design problems and borrowing from nature, whether it's material science or the shape of a fan or the shape of a bird's wing. We can study from nature and study the way that that studies nature's system to apply them to the challenges that we are facing. And increasingly, we're finding that software tools allow designers to get more and more people involved in the design process.
Right.
Some of the biggest challenges that we face are infrastructure challenges. There's, I think, $15 trillion worth of infrastructure projects globally that need to be done. And they're complex, thorny, I think they're called wicked problems that have no single correct solution, but involve political negotiations where people at all stages of the at all levels need to be involved in the decision-making process. So digital tools allow the designers to be able to show what a design looks like and design options look like to the decision makers, to the fund raisers, to the politicians, to the people who will be affected, perhaps positively and maybe negatively about the designs. So designing that as part of your process is increasingly an important part.
Right. And of course, crowdsourcing other designers who know specific things about the infrastructure that can all collaborate on one file versus having one file change hands through a multitude of teams with different agendas and different objectives. So
yeah, you're absolutely right. And companies such as Quirky are disaggregating the entire design process. That's what digital tools are doing. They're moving us from this kind of linear, where you're iterating just in a few places, to ways of creating value by iterating in unexpected places. So Quirky is a crowdsourced design practice, and they're trying to be the next GE, and they've actually partnered with GE and have acquired, I'm not sure the full set, but certainly a major subset of GE's patents. And their goal is to produce 3 new products a week, and I think the record was 7 new products a week, every week. And the way in which they do this is by disaggregating or chopping up the product development process. So the traditional way of product development is you have a bunch of people working inside of your design firm who come up with ideas, and they work with marketing, and they work with business development, and they pitch ideas, and typically it's a multi-month project.
Right.
With the evolution of crowdsourced tools, instead, what Quirky does is they bring together many tens of thousands of people who pitch ideas of consumer products, which are then vetted by the crowd that then go up for a kind of debate, or actually it's a pitch. So each week they have 3 pitches, and they're curated by the manager. So instead of having a few product developers, they've got tens of thousands of product developers,
right,
each of whom will make some small contribution to the product, and they get some small percentage of the profits of the product. That's pretty interesting. And so what Quirky then does is they take those ideas that are through the crowdsourcing product. They're kind of doing their market research, and then they put it through the Quirky machine. So Quirky then streamlines the part of the design process, so they get really good at the manufacturing part. They don't need to outsource so they keep the development process really tight and capitalize on what the crowd can offer for both ideation, exploration, voting, what they think would work best, testing, and of course they've got a bunch of customers that are interested in the product.
Right.
So that's an example of another example of innovating the system rather than innovating the product. Other examples of the impact of technology on chopping up and kind of mashing up the design process includes what Jim Cameron did in the making of Avatar and Avatar 2 and 3. Which is, rather than just filming a movie, instead the action is being sampled. So a 3-dimensional performance is captured of the performers. And so that goes into an interactive three-dimensional digital model, and the facial expressions are captured and so on. And that enables many interesting things to happen. First, it means that you don't have to worry about things like lighting,
right.
or having the perfect performance or the performance timed correctly every time, because you've sort of captured the three-dimensionality of it, the audio you've captured, and then in a playback mode you can speed things up, chop things here, select the camera movements later, and then they're rendered out in high-quality computer graphics. Other aspects, as I'm sure many of your viewers have seen, are these interactive cameras that allow the director to walk through a physical space and see the performance as if the performance were taking place. So let's think of this as a portal, whether it's an iPhone or a tablet, where that looks into the physical space and projects the places of the actors. So taking advantage of how a director normally thinks and works by moving around in space, changing where the camera is, he or she can redirect the performance as if the actors were there, but they're not. They're just being played back and scrubbed through the digital portal. So another example of being able to allow a director to get more creative control. But it's trade-offs, right? Because on the one hand, you get, the value of the performance is then moved from one part of the production process to another. And we're certainly seeing that in whether it's the making of quirky consumer products, or what, a large consumer like a large manufacturer would produce, like GE or many others. Or the folks working with 3D maker bots, with inexpensive software. We're finding design is changing. It's rapidly transforming, and what's driving that, of course, is the technology and the creative power that people now have with this new technology and new social tools.
On the note of MakerBot, with all the recent developments in additive manufacturing and the plethora of available resources online for creating, where do you see the maker movement heading in the next 10 years, and how will it disrupt traditional manufacturing, in your opinion?
I think the maker movement will continue to grow because it for lots of reasons. One is that it enables just about anybody to create personalized products, and 3D is just a small part of it. I think what is the bigger story is the capability to unleash our personal creativity and to be able to innovate more fully, because we have these new sets of relatively inexpensive tools.
Definitely.
So I think that's a big part of it. But the trends that are affecting the individual maker movement are absolutely affecting the manufacturing industries. And I think manufacturing is being shaped by at least a half dozen big forces. The first is robotics. The next generation of manufacturing robots, automated, sophisticated robots, are totally transforming manufacturing at the high end. And so whether it's cameras or cars, if you're not in the robotics business, you will be outmaneuvered by those who are. Secondly is the advancements of 3D printing or additive printing. Now, the thing about additive printing is that it exists just about everywhere on the hype curve. So it's on the really high. The hype curve is this curve of high expectations and this trough of disillusionment, and then followed by a plateau of productivity. And depending on where you are in the manufacturing industry, it kind of occupies just about every place. It's the Gartner report said that it's at the very top of the hype curve when in consumer 3D printing. So, we have this promise that a 3D printer will be able to duplicate just about anything in our home. No, not so much.
No.
It's still not. But on the other hand, there are a wide variety of industrial processes that you do use 3D printing and have used 3D printing for quite some time, whether it's prototyping or companies like Invisalign that make braces.
Yeah.
They produce, I think, 70,000 3D, unique 3D printed braces every day. It just
Wow.
seems huge. And it's a very viable business.
Yeah.
General Electric is using it to print functional parts of their airplane engines. So, of course, these are not the vanilla MakerBots. These are very sophisticated 3D printers.
Right.
So 3D printing, which is a kind of robotics, of course, will continue to advance as chemistry advances. The third area is emerging materials. These, whether it's assembling materials or materials with remarkable physical properties, there's a world of these that will affect the way in which our clothing, our cars, and we need to better understand how to use them.
Right.
So, for example, a roof of a typical mid-sized car weighs around between 65 and 70 pounds traditionally, but made out of carbon fiber, it's around 12 pounds. But the carbon fiber manufacturers say that if we just design it optimally, we can get it down to 6 pounds.
Wow.
So there's next new tools to be able to generate that.
Huh.
That's pretty crazy. Another trend is something called new sourcing. That's a word that I just stumbled on a few weeks ago, which is not outsourcing or new sourcing, but figuring out the right source of talent to be able to build products. And so we're finding that certain kinds of manufacturing are coming back to the United States. I don't think the low skilled kind of hand assembly stuff will, but the high-end stuff certainly is. Detroit is now has become the center of transmission creation for Ford globally. They're just going to concentrate it there, so that's great news.
Yeah.
Apple, of course, has got the new manufacturing facilities that they're building in the United States for the Mac Pro, so good news there. Whether it's crowdsourcing, as we talked about earlier, or open source hardware such as the Arduino technologies, or the incorporation of sensor technologies so that we have smart buildings and smart clothing and smart objects and smart refrigerators.
Right.
That potential, that promise is now coming to the forefront because of the low costs that are associated with it. So there's no single trend that's driving it, and different industries will be affected by each of the trends to varying degrees.
Now, we're going to shift gears a little bit here. I know a lot of industrial designers will get excited about this question, but you were involved with the creation of Autodesk Maya and the popular Sketchbook Pro. What was your involvement with these tools, and how have you seen them change over the years as hardware has gotten better and more users have picked up these tools?
Sure. Well, let me tell you the story of Sketchbook. Back in 2001 and 2002, Microsoft announced the tablet PC. Actually, I'm holding a tablet PC here, Microsoft Surface.
Oh, nice.
And so there was the potential, we thought, and many other people felt, for this to be able to digitize handwriting and digitize sketching. We had a product called Studio Paint, which was an application that needed to run on Silicon Graphics Infinite Reality engine. It's a high-octane computer. Required about $340,000 of hardware to be able to run this software. The software cost about $45,000.
And when was this?
Mid-90s.
Mid-90s, wow, okay.
And of course, this iPhone 5 has not only higher graphic processing capabilities, but more storage and a faster processor speed, I think by a factor of 10 than the $340,000 in reality. It's like...
Gotta love Moore's Law.
That's crazy. And it's true, that's the actual relationship of it. So in 2002, we thought, there might be an opportunity to take these new tablet PCs and take this $40,000 software and make it a lot more affordable, say $200. And of course, it was because of the graphic chips, Moore's Law. And we produced the... actually, there's a a funny story about it. My compatriot in this venture, Ian Ameline, and I at Alias thought, why don't we approach, see what Microsoft is doing? And I paid a visit to Microsoft and asked the question, are you guys going to be building a paint application? Mm-hmm. And they said, no. And I said, are you sure? I said, yeah, we're not going to do that. We're going to let third parties develop that. And we went, great. So we came back to Toronto and made a product pitch. We thought we needed 6 engineers for 6 weeks to build a prototype. We got 2 engineers for 2 weeks to build a prototype. And we brought it to we had, I think, some pretty interesting innovations, really good brush and stroke capabilities, gestural-based interface, and the underlying technology was actually built on the $40,000 software. It was actually really sophisticated.
Wow. And
it worked super well on the tablet PCs. We actually codenamed the product Smack, and because at the time Alias had this really terrible track record for having the code names turn into the actual product names, but we thought that no one in their right mind would ever name anything Smack.
Right.
It's like a joke there. Anyway, so we called it Sketchbook. And we developed the product. We actually won a number of prizes and awards for the product. But the part that we thought was unique and special about it was focusing on the customer experience. And what we wanted to have this product do is to, unlike Photoshop and the other products at the time, to be able to launch immediately within half a second and to produce the best quality brushes. And we did a third thing as well, which is to design a user interface that promoted this feeling that pretty much every designer knows, which is flow. And flow is the state of mind, or some people call it a state of being or working, in which everything just kind of fits together the right way. You're just so focused on the task at hand that you're no longer paying attention to anything else.
Totally.
Flow happens when certain conditions are met. You have that clear task that you have a chance of completing, moment-to-moment feedback, and you're not distracted. And when those conditions are met, most people get into flow. Those conditions are what we designed into Sketchbook. We wanted to make it a minimal user interface that didn't interrupt people, but enabled them to draw with the minimal distraction. Let me just show it to you. So, okay, let me just get this in here. You probably can. This is a current version of Sketchbook here, and I'm doodling on my tablet PC. And the part that I think is really interesting is that there's a whole range of digital tools that I can get access to with a simple flick of a brush stroke. So we've been able to allow people to get to a whole range of digital tools by simply using a gestural-based interface. So Sketchbook did fine in the marketplace, but then the tablet PCs, of course, didn't do so well because it didn't hit the needs of the broader consumers. And that all changed, of course, when these devices came out.
Right.
And one of our product managers, a fellow named Chris Chung, had the idea to do a skunkworks project of figuring out, what if we did Sketchbook on the iPhone? And it was interesting. It met with a rather huge amount of skepticism and pushback from from people within the organization. Mm-hmm. Why would anyone do any drawing on a sketch on a little tablet? Or why, with their finger? Are you nuts? That makes no sense. We have professional customers. Well, fast forward with more tablet PCs. I think we have over 30 million people using Sketchbook now on iPhones and iPads and Android devices, and it's become our number one marketing tool. So people, I walked into Apple stores and I bought something, and they go, "Oh, you're from Autodesk. You made Sketchbook."
Wow!
And I think that's crazy. And it's actually that was a product that then helped us create a whole consumer strategy. So we have a whole range of products that we feel are satisfy the needs of people who are not necessarily professional designers, but want to build 3D models, want to be able to take photographs of something with their iPhone or their iPad and create a model that they can modify. Soon, be able to print them out using various types of technologies. So these, and what used to, I began talking about the Mysore project, which I was kind of my leaving the content creation world. And I guess that was in the mid '90s, and I remember we had we created this physical model of this dinosaur, and it took some months for the artist to create it, and then we needed to digitize that model, and it took forever. It took weeks and weeks to get a good digital model. We build it and then throw it away, and build it and the geometry wasn't right, and we threw it away.
Yeah.
And I happened to visit the museum just a few weeks ago, and there was this brass model of this dinosaur, this Mysore, on display, and I thought, I wonder, and I took out my iPhone, and I took a dozen photographs of it, and from different points of view, and I brought it into a program called 123D Catch, which is one of our free software applications.
Yeah.
Took those 20 pictures and then uploaded it, and then went to another part of the gallery, and maybe 3-4 minutes later got a message saying, your 3D model is now complete.
Right.
And then I, on my iPhone, had this 3D model, which of course could then be, could be transferred into an animation software. And the thing was freaking perfect. It's like, holy mackerel.
Right.
It took me and cost a lot of money to hire additional animators, can now be done on a device that's, and it cost. It was free, and that's how far the technology has advanced in a few short years.
Totally. Or you could even take the model and create your own 3D print to put on your coffee table.
Right, and I could do that now.
Yeah.
Or then put it into animation software. So that was and I explained to my wife and kids, who went, oh yeah, so what? But it's like it was a big deal. So you wonder what it's going to be like in another 10 or 20 years, where this kind of capturing may be going on concurrently, or our ability to print these things out using printing biological matter. That's a reality now. It's at the early stages. So I think people who work in design think that we're at this cusp, where these exponentially growing technologies and these new business models are going to change everything. They're going to change the way in which we design and manufacture cars, the way in which we manufacture clothing, the way we manufacture and build homes. And what seems to be sort of almost impossible now will move into the realm of the possible, into the realm of the expected, and eventually into the world of the required. What was impossible just a decade or two ago is now trivial because the technology has enabled us. And but what's really important, I think, is not just the technology of design, but the tool set of design, but the mindset of design. Figuring out what problems we need to solve, figuring out how to take advantage of these technologies to get to the best possible solution, to collaborate much more effectively, to produce works, as many of my customers say, hang in the halls of coolness forever. And that's important. And I think that's what great design is. It's taking advantage of these great, amazing, evolving tools, but producing stuff that's really relevant and really matters. And when you do that, I think you're doing the contact sport of design. You take advantage of the collaborative work, you build up prototypes. It's not an easy, linear, it's a very messy, collaborative practice. But boy, it's really rewarding. And for people that are in the world of design, there's probably kind of nothing better.
Totally. I completely agree. And so how can a designer or engineer position themselves in the best possible way with what you just said?
So that's a great question. And so where's design going? What should designers pay attention to? And I think the right thing to pay attention to now is designing systems.
Okay.
And what that may mean different things to you depending on what you design, but upscaling your design skills so that you are designing not just the object, but the ecosystem of the object, making sure that it has value throughout. Other folks, it might have to do with designing even business models, not just the evolution of the product, but how the product is sold and who buys it and the way you market it. And so we're finding that people who are doing that are magnifying the value of design. So magnifying the value of design, what you do uniquely better than anyone else can, which is taking your creative insight and capabilities and skills in drawing and modeling and animation and testing and put it into a context that it's insanely valuable to other people, is an exercise in figuring out the system. And I think that's where design is going.
Where will we see you in the next 10 or 20 years, Tom?
I think in 10 to 20 years, I would love to create tools where that becomes a digital process so that we could work. I mean, we've all seen Minority Report and kind of the emerging 3D interfaces, but I'm really excited by the potential of those new types of interfaces to be able to bring bunches of really smart people together to figure out really complex problems. And so I hope to be continuing to do this kind of work, but to amp up the tools, to take advantage of our creativity so that we really are dealing with the big grand challenges.
Great answer, Tom. Thank you so much for being on the show today.
It's totally my pleasure. Thanks for having me on.
This show is brought to you by CADjunkie.com. Step up your 3D content creation game with hundreds of video tutorials ranging from footwear design to 3D printing. Get a free membership now over at CADjunkie.com. Thanks for listening in today with us, and if you'd like to find out more on Tom, be sure to check out his website at tomwujec.com. On our next episode, we'll be talking to the CEO and founder of one of the Wall Street Journal's top 10 startups of 2013 about developing a revolutionary product, Mr. Stephen Ambrose of Acius Technologies. I'm your host, Simon Martin. Stay tuned and check in with us next time on Maker Galaxy.
A production of EBD Media.